This lesson is for Advanced Algebra, Lesson 9.9 on properties of logs. Students do not need to memorize the names of the properties, but they do need to recognize which properties to use, when, and how to apply them. The first property is one that students already know. Whenever you take a number and raise it to the 0 power, students should know that that always equals 1. So when you convert that idea of taking a base and raising it to the 0 and getting a 1, that's an exponential form. If we turn that into logarithmic form, its log base b of 1 is always going to be a 0, because the 0 is the exponent. So there's no examples of that. I think that's just one that students need to memorize. If you get a log of something and the answer is a 0, you know that you're taking the log of 1. The next theorem, notice that the base here and the thing that you're taking the log of are the same number. So in that case, if that base is being raised to a power, then the power is the answer. And I think most students would probably be able to recognize that pretty easily anyway. But as you look at the three examples here, you can clearly see what the answers will be. Since this is a base 10 and we're taking 10 and raising it to a 4, the answer is simply going to be a 4. Here the power is a half, so that's your answer. Here the power is 27.2, so that's your answer. Let's illustrate why by turning that first one into exponential form. Since it's a base 10, and I don't know the power yet, I'm going to assume I don't know that number, then I'm going to try to turn it into 10 to the 4th. So you can see here that when you do write it in exponential form, the exponent is pretty clearly indicated that it's base 10, we're raising to the 4, so the missing exponent we need is the 4. So that's what would happen on both of the other two examples. Whenever you're doing log problems, it's important for you to remember that you should always simplify as far or as much as possible, as far as you can. So there may be instances where you'll use a property and then you'll use your knowledge of logs or other mathematical items to finish. The first property here is called the product property. Again, students don't need to memorize it, just know how to recognize it and how to use it. You'll see here that on one side of the problem we've got a single log where the two pieces are being multiplied together. On the other side we've got two logs where they're being added. So what students need to remember here is that when you're adding two logs, that can turn into a single log with multiplication. So that's a property that will be very useful to students when you look at the two examples listed here. Notice that the bases are the same, and that has to be true for the property to be used. If the bases are the same and you're adding two separate logs, you can turn it into a single log, base being the same again, in this case it's a 6, and we take the 2 and the 108 and we multiply those together. When you multiply those together, you get 216, and now we can use our knowledge of logs to simplify. Let's fill in the missing piece. We don't know what the exponent is, so I'm going to fill that in with a question mark. So if I rewrite this in exponential form, it's base 6, I'm raising to an unknown power, and I'm trying to get to 216. So now you just have to use trial and error to figure that out. I know it's going to be bigger than 6 squared, because 6 squared is only 36, so I'm going to try 36 times 6 to see if it's 6 cubed. And it is, so then my final answer there is 3. Let's utilize that same property again to do the next example. I've got two log problems that I'm adding together. They have the same base, so I'm going to turn that into a product or multiplication. 5 times 45, and then I'm going to figure out what that is. So I would just type that in on my calculator. 5 times 45 is 225. And so now I'm going to use my knowledge of logs to simplify. It's a base 15, I'm raising to an unknown power, and I'm trying to get to 225. My first guess, or my first instinct, is that it might be a square, so I'm going to write 15 times 15 on my baby calculator, and that works. It turns into 225, so then my answer there is simply a 2. So addition and multiplication go together for one property. Next property is very similar in that we're going to turn subtraction into division. Just be careful on this quotient property. You do need to pay attention to the order of things. The x, or the first log, needs to go on the top when you do your division. So make sure you don't flip-flop those by mistake. So on our first example, the logs are both base 3. We are subtracting, so I'm going to turn that into log base 3 of 2 divided by 18. It would definitely be more convenient if this said 18 divided by 2, but then that would be going in the wrong direction. So make sure you always do the first log divided by the second. We can go ahead and simplify that 2/18 into log of base 3 of 1/9. So then when I rewrite that in exponential form, it's a base 3, the power I don't know, and I'm trying to get to a 1/9. Remember that when the base is now on the bottom of the fraction, you're going to need a negative answer, and then we need to figure out 3 to the what power is 9, and hopefully students know that that's a 2. So then our final answer there is -2, because a negative exponent will flip over the base. Let's try that one more time on our second example here. Since I see that I've got two logs with the same base that I'm subtracting, I'm going to turn that into log with the same base, and I'm going to turn it into division. So I'm going to do 85 divided by 17. Now hopefully those numbers will work out nicely for me, and they do. They turn into a 5. So I'm really doing log base 5 of 5, and hopefully students know, even without writing that in exponential form, what the answer is going to be. But let's go ahead and do it. It's base 5. I'm raising to an unknown power, and I'm trying to get to the number 5. So clearly there the exponent needs to be a 1. So what's cool about these properties is if you look at the one we just did, if you tried to type in log base 5 on a baby calculator, there is no log button, so you normally would have been stuck here. You wouldn't have been able to figure this question out. But because we used a property to simplify it down to a single log, we could divide here and we were able to come up with an answer where normally we would have been stuck. I also want students to just take a quick peek here. Remember that addition turns into multiplication, and division and subtraction go together as well. So addition with times and subtraction with division. We've got another property to learn. This is our last property actually. And I want to point out one quick thing before we get there. There will be situations where you'll see more than one property occurring in a problem. And so in those situations you should do the order of operations just like you're used to. There is, however, a property that takes priority over the others, and that's our last property here. It's called the power property. Notice that this one is different from an earlier property we did today. Earlier property had log base b of b to the n, and so our answer was just n. Here, the base and the thing we're taking the log of are different. In that situation, the n can be manipulated to either be a power or a number that you're multiplying by in front of the log. So this is a very useful property. We're going to use it when we get to the next lesson in lesson 910. So you can use this property in either direction. For our two examples here today, we're going to use it in this direction. The number is going to be in front and we're going to turn it into a power. But know that you can also use it by moving the power to a number being in front. So let's take a look at our first example. There's a 2 in front of this log, so that means 2 times the log base 9 of 27. So I'm going to move that 2 and turn it into a power. So if I rewrite my problem, it's still going to be log base 9, it's still going to be of the number 27, but now that 2 is going to become a power. So 27 squared is 729. So now I'm in a situation where I can just use my knowledge of logs to rewrite this in exponential form and then try to solve. So it's a base 9 problem. I'm raising to an unknown power and I'm trying to get to 729. So now I would just do some trial and error there to figure that out. I know it's going to be bigger than 2 because 9 squared is only 81. So I'd probably try 9 cubed next, and cubed works. So 3 is my answer. The next one's a little bit tricky because we've got a square root, and we haven't really done much with square roots and logs. Most of the time when we have a square root, we know that our answer is going to be a fraction, but in this case, because of the 2 in front, we're going to worry about that more than the root. Just like what we did on the previous one, the 2 is going to turn into a power. So I'm going to rewrite log base 6. I'm going to put the 6 square root of 6 in parentheses because both of those need to get squared. And that square is because of the 2 that used to be in front. Now let's just do a little scratch work off to the side here. If I do 6 square root of 6 times itself, let's see what happens there. This 6 and that 6 are going to multiply together to make 36. And then I've also got square root of 6 times another square root of 6. And hopefully students remember that when you do the square root of 6 times itself, you just get 6 back. So really what I've got there is 36 times 6, which is 216. So when I took 6, square root of 6, and squared it, I ended up having the problem log base 6 of 216, which we did today earlier. We know that that answer is going to be a 3. So again, we started with a problem that looked kind of scary because it had square roots in it. We used a property to maneuver the number to become a power. We simplified, and then we used our knowledge of logs to complete the problem. So now let's look at some further examples where more than one property is present, and we'll practice putting the different properties in priority order. So when there are multiple properties to simplify, usually what your goal is to rewrite it as a single logarithm. So our goal is not to find a numerical answer like we've been doing, but simply to write it as log of something. That's our goal. So when you look at the problem, try to figure out what types of properties are happening. Clearly we've got a minus, we've got a plus, so those are two different properties I'm going to use there. Then I want to quickly scan and see if there's anything else going on. And I see right here I've got a number in front of a log. And remember that that property takes priority over the others. Always do this property, the power property, before any others. So that's what I'm going to do here. I'm going to take that half and I'm going to put it as a exponent on the 25. So I'm going to get log of 25 to the 1/2 power. Now hopefully students remember that when you take the 1/2 power of something, that's the same as taking the square root. So this is really going to turn into log of 5, because 25 to the 1/2 is just like taking the square root of 25. Now I'm going to rewrite the rest of my problem here and try to figure out what I'm going to do about the rest of my properties. Now I've got subtraction and addition, and I want to make sure that I know what priority order to go in. Subtraction and addition, according to the order of operations, carry equal priority. So then what we do to figure out which one to do first is we simply go left to right. So we're really going to do the minus here first, and remember that minus turns into, that's right, division. So I'm going to take log 85 over 17, and then I still have to add on to that the log of 5. So 85 divided by 17, I know that that from before turned into a 5, and then this log of 5 is still there being added as well. Addition is going to turn into multiplication, so my final answer there is going to be log of 5 times 5, which is just log of 25. That's as far as we can go on this one. We wrote our answer as a single logarithm, which was our goal. Let's do one more there. And when I scan this example, I see that I've got plus again, and I've got a number in front of a log. So I'm going to deal with the number in front of the log first, because that property takes priority. That 4 is going to turn into an exponent on the 2, and the log of 3 that I'm adding is just going to wait for me to finish up what's going on over here. The 2 to the 4 is log of 16. Now when I deal with my addition, that turns into multiplication. So I end up with log 16 times 3, which is 48. I'm finished now because I have my answer as a single logarithm. We've got one more thing to look at today. Once in a while they ask you to use properties to solve, and I think that that's a little bit misleading. Most of the time when we're asked to solve, we do things on both sides to try to isolate the variable, and that's not entirely true on these types of problems. What you're going to do is try to manipulate either one side or the other using a property. So as I look at the right-hand side here, I see that there's addition going on. Based on what we've learned today, I know that that's going to turn into 5 times 12 with a single log instead of 2 separate. So if I rewrite my other side, now hopefully it's becoming clear that the x value is staring us in the face. The x value is whatever you're multiplying the 5 by. So on the left I've got 5 times x, on the right I've got 5 times 12. So clearly the x is the 12. So notice how we didn't use algebra here to do things to both sides to isolate the x. We were just using the property to rewrite it in another way.